In this demo, we're going to take a look at function and class decorators. First of all, what is a decorator? It essentially augments a function or a class's definition. It doesn't actually change how the code runs by default in Python. Other libraries or functions have to be looking for these specific decorators for any change to occur. Let's start by looking at a simple class, and I'll call it test class. It'll inherit from object. That's where we'll start from. And then I'm going to create several methods in here. We'll create one called instance method, which must have a self parameter and some value x. And then I'm just going to print the values as a list here, self and x. So we're going to have to create an instance of this class to call this method. So we could say test equals test class, and I can pass it, I don't need to pass that there, I need to actually say test dot instance method, and then I'll pass it a value. So let's make sure that class is run. You can see here when I call instance method, I do it on the object itself, test.instance method. I pass it a 1, and it prints out self, whatever that happens to be. In this case, it's test class, and then the value 1, which is what I passed. So that's a standard instance method. All of our classes that we've created up until now pretty much have had one. But let's go ahead and create another method called static method. Now, static method, unlike an instance method, is one that we will not require an instance of the test class to call it. So let's go ahead and we could say test class. I'm having trouble holding on to the caps today. So I keep holding it down for the class. The L is always capitalized. So we have test.static method, or testClass.static method, and then we'll pass it a 2. Now, right now, there's no issue with us calling this. Could we also do it with the test handle? See, right now, it's failing because it was expecting us to pass in, because it's an instance object, it was expecting us to pass in a self parameter, which, as you can see here, we're not accepting one. So one thing we can do to fix this is to add a decorator called static method. Now, when Python is run, or when this class is run through Python, Python itself will see this static method decorator and treat this static method call slightly differently. And now you can see I can call static method whether or not I use the class name or an instance name of that class. And this method doesn't belong to a particular instance. Like, we have this thing called test, and yes, I can call static method on there, but in fact it is a static method, which means it works as a function on the class, not on an instance. That's the whole point of what a static method is, as opposed to an instance method, which requires an instance of that object. We can also create another version of this method. I'll just copy it. And this time I'm going to call it class method. Okay, and unlike static method, I am going to accept a parameter. This time I'm calling it CLS, which is going to represent a handle to the class itself. And let me change this to the class method decorator. Now I can add several calls. to this class method. And we'll do 4 and 5. Okay. And we'll run this. And as you can see here, it doesn't matter if I call it on the class name or an object. That first parameter is now always going to be a handle to the class itself. Notice it's not a specific object. Right here, the first one, where it's passed in the self, essentially, where that's a particular instance of this class. Notice here, regardless if I call it on the class name or an instance of it, that first parameter, CLS, is now always going to be a pointer essentially to the class itself, not a specific instance. And then finally, another decorator that we've encountered before is the property decorator. We'll call this one name, and it is going to be an instance member, and actually it's the double underscore name property of the double underscore class member of this object. This one must be run on an instance, not the class name. So I'll have to say print test.name, and now it's going to return the name of our class, which is test class. That's what this name is. If I got rid of the .name, you'll see something familiar. It's just going to be the class main test classes, which is what we were seeing before with this CLS parameter. But this and this, the CLS, which is automatically determined when you have a class method decorator, we can get to manually from any instance of that class. We can take the self object, go to the double underscore class object, and inside of there is a double underscore name, which allows us just to see the name as it appears here right after the class definition. Okay, so those are some built-in decorators. The whole point of this exercise, however, is to go beyond that and start to use our own. So let's go ahead and create a function called log. And this is going to be a function decorator, very much like these up here. They're applied to methods. So just like the static method, class method, and the name property, we are going to define a special decorator that can be applied to functions. And I'm going to go ahead and start putting this together, and I'll explain things as I'm going. So this function is going to define an internal function. And as you're aware, this is very much a higher order function because we are going to return from log this call method. Okay, so essentially what we're going to do is intercept any calls to the methods that we're applying this decorator to. All right, let's go ahead and then we'll say call.counter plus equals 1. And this is kind of interesting because if you take a look at this, call is a method. I'm assuming it has something called counter in there. But in reality, it doesn't have a counter. But because functions are first class entities in Python, it allows us to treat it like any other object. So this function can have members or attributes. So we're assigning this counter variable to the call function inside the log function. Now we could have created some state information instead inside of this def log. I just wanted to show you this neat little trick because it could come in handy. Then I'm going to make a call to print where it's going to indicate how many times this function has been called. and what are the current parameters to the function. Now, what I mean by that is not really how many times call has been called, but when we attach this log decorator to a function, we want to keep track of how many times that function has been called. So call sets the counter, prints out some debug information, then it is going to return the call to the function, passing it in whatever arguments were passed into that function. So this func corresponds to the func that to the function that this decorator was attached to. Args, when we make a call to any function, we're going to intercept it using this call method, and then it's going to accept any of the arguments that were passed to that particular method. And then we're going to keep track of how many times that method's been called, print out some diagnostic information, and then finally actually execute the method that the user was attempting to do. And then right before we do the return call, we do have to initialize call's counter to something. Okay, so we've defined the function, but we haven't executed it yet. So we're able to define the method in here, set its counter variable to 0, which we will augment once we start actually calling the method that this decorator is attached to. Okay, I've said a lot of interesting stuff, but this probably makes very little sense to you right now. So let's make it make sense. Let's define a method called power, which is going to accept a base and a pow value. It's green because pow is actually a function. Return base raised to the power. And we're also going to define an add function, which accepts an x and a y, and we're going to return x plus y. There's nothing special about these methods. Let's go ahead and run them. We could just demonstrate by calling them several different ways. Instead of me typing them, I just quickly paste. So we look at these functions, and as you can see, 3 to the 2 or 3 squared is a 9, 2 squared is a 4, 4 cubed is 64. Adding 3 and 2 gives you 5, adding 2 and 2 gives you 4, adding 4 and 3 gives you 7, and then finally 2 to the 3 is an 8. So there's nothing special about these functions. Watch what happens when I add this simple code to each of them. So now they both have the log decorator associated with them, which is essentially this function right here. Now watch what happens when I run it. Every time we make a call to power or add, it prints diagnostic information, which is essentially what was in here. So let's take a look at what actually is happening here. We've defined this log function, which contains an internal function called call. The function call augments a counter, prints out diagnostic information, basically the counter value, the name of the function being called, and the arguments that were passed to it, and it returns whatever function this log decorator is attached to. It executes that function using the arguments that were passed in. But when we initially assign log to this def power is when the setup happens. Okay, actually let's go ahead and put that in here, and I'll say print setting up, and then we'll call it log on. Let's make it an f print. There, on that function name. So let's save this, and I'll step over this, and now we're not actually executing power and add yet, but watch what happens when I just run the methods to put them into the Python kernel. You can see that's when the setting up calls are done. Okay, so that's what's happening initially. It's now ready for any time that we make a call to one of these functions, either power or add. We've kind of hijacked the call, and it is going to have to essentially execute this closure, this call method that we have defined right here. Okay, so when we say power 3.2, it is actually calling this call, which is wrapping the power call. So we get args, which is going to be 3.2. It augments the counter for every time we call the method, print out that diagnostic information, the call number, whatever, to the method, and what are the parameters. And then it returns the execution of whatever method we attach log to. So in essence, then, that's when this gets fired, because it's going to call func, which was the func passed in using this decorator. Okay, so it just gives us the ability to add things automatically to these method calls like logging without really affecting how these methods are getting called. That's not to say we can't tweak something here. We could not pass args, or we could flip the order. We could do whatever we want to args here, which would mess with how they execute. That's not what we're trying to accomplish here by using these decorators, but nothing would stop us from doing that. And it could be useful if we wanted the ability to automatically update a database based on some of these calls. So we could have our own custom methods that work with databases. This is kind of like how some of the ORM tools like SQL Alchemy work. So we can do whatever we need to then once we've attached a decorator to those methods. We can inject code. We could physically do something to the arguments, like check to see are they integers, in which case I want to convert them to floats, or vice versa, and fix things before the methods execute. So there's a whole bunch of stuff we could do now just by simply attaching these decorators. But just so you know, the decorator itself doesn't actually change the code of this method. There are other techniques we could do to do that, but that's not what we're going to accomplish with these decorators. We can also apply decorators to a class. So let's go ahead and create a new function definition. I'm going to call it class log. Now, class log is going to be applied to classes, not to functions. It is a function, but it is a function we're going to use as a decorator for a class. And let's say we had a person class. Again, I'll save you the pain of watching me type, and I'll just paste it here. It's a simple class. It has your constructor, which accepts a first and a last name, and it just has the str function. So it's not that sophisticated. And then I could create an object of this person type. Okay, so let's go ahead and say person P is equal to, or not person P, we'll say P is equal to person, and then let's pass in Smith and John. Okay, and there we have it. We've created an object of type person. We have not attached this to the person class yet, however. We want to put as a decorator class log on the class itself. So now watch what happens when we run the person class, not an object of it, but actually run the class. You'll see that, hey, the person class was run. It's not really what happened, but it's the first time the class is encountered and run through by Python, where it now knows what a person class is, so we can start creating objects of that type. And then if we run this person constructor, you'll see nothing special has happened. Okay, so unlike when we were attaching these decorators to a method, and every time the method's called, we would get some notification. That's not what this particular class log decorator is going to do. We can, however, start to use these decorators to get that capability, because we can create a wrapper around classes so we can intercept the messages to the init function or anytime we try to access one of its members. So let's go ahead and start putting that together. We will go ahead and create another class log decorator function, and I'm going to keep track of all of the instances inside of this this dictionary. Okay, and then I'm going to create an internal wrapper class, which is going to be essentially a wrapper around whatever class we attach this decorator to. So anytime we start talking to this class and start manipulating it by creating objects or calling members on it, this in a way intercepts all those messages. It almost works like a base class. So we need to intercept the init member. We'll say if not class name in instances. Then we'll say instances, because we're going to use the name of the class as the key in our dictionary. And we're going to say we don't have any instances yet because it doesn't have it inside of this instances dictionary. Then we can say, I'm not going to type it again, the value stored in the dictionary at this key, we're just going to augment by 1. So this only gets called if it's the first time the wrapper has encountered that class name. Then I'm going to print some diagnostic information. We're going to say creating instance number, so it's going to retrieve the count out of the instances dictionary based on the name of the class of that class name. So it's going to tell us how many times this particular class has been created then, how many instances we have. Then we are going to attach to the self parameter that was passed in a wrapped method and is essentially going to build that object, whatever was passed in. So whatever class is, if it's a person, then it's going to build that person object using those args. But we also can intercept, let's do the get attribute method, and this one gets fired anytime we ask for a member of a given class, like last name or first name. When we say p.lastname or p.firstname on this p object, that's actually going to now go through this get attribute method, and I'm going to print saying getting the name, whatever the name happens to be, value of self.wrapped. So whatever parameter they're looking for, if it's last name, first name, etc., of a particular object. And then I'm going to return, I actually want to call the get attribute member, passing in the wrapped object and the parameter we're looking for. By the way, this is a back-end way of getting a value from a given object. So if we had this person here like this, we could say print get attribute P last name. You can see it says Smith. We would never do that. We would actually say print P dot last name like this. But this is just Python's way of being able to do things using essentially something called reflection, being able to access its own members or members of other classes. And this is the method to get to those particular members. There's other ones as well. There's set attribute if you were trying to assign something. So there's a whole list that you can look up. But we're only interested right now for this example of get attribute. And then when this class is being initialized with the decorator, we're going to return the wrapper. Okay, so wrapper is now going to essentially stand in place of whatever class we assign the decorator to. Hopefully I didn't miss any code there. And then I can create a class, I'll call it dummy, dummy1, and then we can assign class log2 to it. And this class, let's not actually add any code in there. Let's just make it really a dummy class. And the only thing inside is a pass, which is basically no operation code. Okay. So now, as you can see, we have not gotten any diagnostic information this time. What's the difference? Well, before, when we created class log, it was going to, anytime we access or create the member, we had this print statement. So let's actually put that in there, and now we can see that as well. That way it's similar to what we had before. Now you can see the dummy class was run. Okay, so that means we have attached this decorator to the dummy class. This, however, the init is now going to get called when we create one. If we say d1 is equal to dummy1 as such, now watch what happens when we run this. It'll say creating instance 1 of dummy1. Let's create another one. Now it's saying creating instance 2 of dummy1. So that's when these are getting called. But what happens if I wanted to actually access a member? Well, dummy doesn't actually have any members, so we'd have to change our code and throw in, let's throw in an init, and we'll just say self and x. We could say self.x is equal to x. Okay, you can still see the dummy1 class was run, but now when I create the object, I'm going to pass in a parameter, which is going to represent the self.x. Okay, so we get the same thing, instance 1, instance 2. But watch what happens now when I try to print the x from dummy1. It gets us the 1, which is what we assigned, but watch what it says, getting the x value of this object. If I do it for dummy2, I would expect to see a similar result, except it's going to give us a 2 back, and the object address should be different. You can see this is DC88 as opposed to D9E8. So we definitely then are getting 2 different x's because we have 2 different objects, and they have 2 different values as well, but we're able to sniff those events when they're happening. So when we're retrieving an element from an object now, we can handle that. And we could actually manipulate things a little bit as this is happening, because we actually do have the self and the name. So what could we do with that? Well, we could set values as well as getting them. I don't really recommend that It's one of the dangers of Python. You can pretty much do whatever you want, but it's not necessarily the best approach. So I would use that kind of functionality with caution. Now, what is the benefit of using a decorator like this? Well, clearly, in a lot of ways, we've just created a base class when you look at what we did here with this class decorator. So it wasn't anything really fancy as far as what we accomplished. However, it does show you, if you wanted to be able to log this information to see what your classes are doing, in other words, who's accessing them, what they're pulling out of the objects, you now can track this. It doesn't have to be printed to the console. It can be saved to a file. So very simply, by putting this decorator on the class, all of a sudden we have the ability to track all of its usage. And primarily, that is what these custom decorators are used for. We can use them again for injecting code as well. In other words, changing how code works. If you take a look here, it's not hard to add values to another object. We kind of did it up here when we did our function decorator. You can see, we were manipulating objects by, in this case, changing this call function to have a different counter. But there's nothing to say we can't actually manipulate the function itself by adding a value to that. Because a function is a first class member, we could have actually added something to that function. Okay? So one of the, like I said, dangers of Python is you can pretty much do anything. But it allows you to be extremely flexible, where other languages, code injection and doing things like we just did here actually takes quite a bit of work. Python makes it very simple. However, again, just because you can do something doesn't necessarily mean you should.